right, so lesson 53 is on polar coordinates and complex numbers. So as you guys know, we have the real number line. And the real number line, you guys are pros at now. You can plot points on the real number line, right? So if I asked you to plot 7, right, -5, or things like -1/2, or 3/4, right? You know where all of these things are. Pi, a little bit more than 3, right? Does that make sense? So we know how to plot things on the real number line, but we're going to talk about the complex plane. So it's a little bit harder. So it says things get trickier with complex numbers. So complex numbers have a real part and an imaginary part. We talked about this back in Algebra 2. Do you guys remember the real part, imaginary part? So if you have the number 2 plus 3i, its real part is 2 and its imaginary part is 3. So when we plot something, we have, this is off to the side over there, but we have a real axis and an imaginary axis. And so if I want to plot 2 plus 3i, I plot it as 2, 3. So that represents 2 for the real part and 3 for the imaginary part. So it's 2 dimensions. Easy enough? I told you this section would not be that bad. All right, so the complex number a plus bi corresponds to the point a comma b in the complex plane. So real numbers can be plotted on the complex plane as well. The number -5 is plotted as -5, 0 because its real part is -5 and its imaginary part is 0, right? So the horizontal axis is called the real axis. The vertical axis is called the imaginary axis. So if I have something along the imaginary axis, it means it has a real part equal to 0. Like if I had 8i, it would be 0, 8. Okay, so we can also talk about the distance from a complex number to the origin. So on the real number line, we call this distance the absolute value. So we've talked about this distance thing before. We've called it the magnitude, right? When we talked about vectors. Guess what? It's coming back. We have the magnitude once again. We've also talked about it with polar coordinates, and we called it the radius, right? Same thing. How do I find a radius or a magnitude or whatever? If I have 2 points, like if I have a point x, y, how would I do? It's the square root of x squared plus y squared. I don't know why I said 2 points, but if I have a point x, y, it's going to be the square root of x squared plus y squared. And we denote this by absolute value of z, or sometimes kind of going back to the magnitude thing, we might have 2. That's why we go back and forth, with some people use 2, some people use 1 line. All right, so the absolute value or modulus of the complex number a plus bi is absolute value of z is equal to the square root of x squared plus y squared. Okay, so it says find each modulus or absolute value. Notice this is just the magnitude of a vector. So we know this. So we're going to do the square root of 5 squared plus, we're going to do -12 squared. And you can find that you get the square root of 169, which is 13. Easy? All right. So this next one, so we have 1 squared plus -√3 squared. So I get 1 plus 3, which is 4. So square root of 4 is 2. The I we just kind of ignore because it's talking about the real part and the imaginary part, and the imaginary part never has the I with it. We're just basically saying if we plotted these points, like if I went over 5 and down -12, what would be this length here? Okay, good so far? All right, so using the definitions of sine and cosine, we write cosine is equal to, so if I have my a plus b, it's going to be my, let's see, adjacent over hypotenuse. It ends up being a over r. So do you remember we've done that before? So r cosine theta is equal to x, right? Do you remember that? Same thing. So and sine of theta is b over r. So therefore a, which is really x, is equal to r cosine theta. And b is equal to r sine of theta. So a plus bi, we're going to have this form where we have a theta and an r, this polar form or trigonometric form. And it's going to look like this, guys. It's going to be r cosine theta plus I multiplied by r sine theta. And you're going to write that 18,000 times. And you're going to get really sick of writing it 18,000 times, and we're going to abbreviate it. So here's how we abbreviate it. It looks really weird. So it's r cis theta. Where do you think the CIS comes from? Cosine I sine. You got it. Perfect. So that's an abbreviation. It's not like a new thing. Like people are like, what is that? Is that like cosecant? No, it's not like, it's not one of the trig functions. It's just a way of abbreviating cosine plus I sine. Okay. So when a number is written this way, we say it's in polar form or trigonometric form. The angle theta is usually in radians. Sometimes we'll use degrees. I'll show you what the ones we'll use degrees on. And the number r is called the modulus. If you slip up and you call it the radius, I'm going to be fine with that. It's fine. But the technical term is modulus. So converting to polar coordinates allows us to multiply and divide complex numbers very easily. So every number z equals a plus bi can be written in polar form. So it can be written as r cosine theta plus I sine theta, where r, that's our radius. Remember we said that was the square root of our x value squared plus our y value squared, so a squared plus b squared. I don't know why I have another equal sign. Oh, maybe it's, I think I wanted it to be like modulus of z, like that. That's fine. You can switch them around if you want. And then a is going to be r cosine theta, and b is going to equal r sine theta. Tangent, what was tangent before for vectors? Yeah, it's sine over cosine, and it was the y value over the x value, right? So same thing, it's going to be the b value over the a value. B is just y, a is x. Making sense so far? It's okay? Okay. All right, and then usually we have theta between 0 and 2 pi, or 0 and 360 if we use degrees, just like normal. Okay, so we're going to express the following complex numbers in polar form and sketch a point. So I don't know if you guys remember this with vectors, but I told you always have to draw a picture. Why did we have to draw a picture with vectors? Because we need to know what quadrant it was in, right? So what quadrant is this one in? So it's 1, negative 1 is the point, right? The real part, imaginary part. All right, so we're going to need to know an angle that's between like 270 and 360. Or you could do between 3 pi over 2 and 2 pi. Okay, this is not a bad one. You guys could probably do this without even using a calculator. Do you guys see it? Yeah, it's like 315 degrees, right? So theta is equal to 315 degrees, or if you wanted in radians, it'd be 7 pi over 4. All right, and then our r is going to be the square root of 1 squared plus negative 1 squared, which is the square root of 2. All right, so we write it in this polar form by saying z is equal to r, which is square root of 2, cosine of theta, 7 pi over 4, plus, you know what, I'm going to pull the r out. I don't know why I haven't been pulling the r out. Sine of 7 pi over 4. So I wrote this up here and I forgot my parentheses. Do you guys see in that box I needed parentheses? That was wrong of me. Because I always say r cosine theta plus I sine theta, but there's parentheses there. Okay, so it looks like that. So then remember I told you there's a shortcut for writing that? So you could also write it as square root of 2 cis 7 pi over 4. Okay, so that's cosine plus I sine. Make sense? You can write it in the short way if you want to, or you can not. I don't care. Some people like to shortcut it. Some people are like, I don't like it like that. That's weird. So it's up to you. All right, this one, quadrant. Yeah, it's in the first quadrant, right? So we go over 4 and we go up 4 root 3. So we're going to have this modulus. All right, so if I was trying to get r, I'm going to do the square root of 4 squared plus 4 root 3 squared. So I'm going to get the square root of 16 plus, that's going to be 16 times 3, which is 48. So we get the square root of 64, which is 8. Okay, any guesses on theta? Okay, it's one that we do know, but you may not know it off the top of your head. So if you start setting this up and you're like, okay, tangent of theta is going to equal 4 root 3 over 4. Do you guys see how those 4's reduce out? Does this make more sense when you see it that way? So remember how we used to do like over 1, and I told you to like divide by 2, divide by 2. So it's saying the sine value is root 3 over 2. The cosine value is 1/2. Now do you know what it is? Yeah, it's like 60 degrees or pi over 3, right? But you could use your calculator. It's fine. Just make sure you're in the correct quadrant. Okay? So this is going to be z is equal to these 8, right? That's our r. Cosine pi over 3 plus I sine pi over 3. Or you could write it as 8 cis pi over 3. See, some of you guys like the cis thing. All right, good? All right, is that it? We got a couple more. All right, so let's try these ones. So go to sketch these out, try to figure out the angle. I would say D and F you definitely need a calculator on. The other ones, so C and E, you maybe don't need a calculator on. So think about where those are located. All right, so I saw a lot of good answers as I went around. So you guys were noticing that negative 6i was just negative 6 down this way, right? Because it's like 0, negative 6. So its theta ends up being 3 pi over 2, or 270 degrees. And its radius ends up being 6. So this should end up being z equals 6 cis 3 pi over 2. Did you guys get that? Awesome. All right, so the next one ends up being in the second quadrant. So it's 1, 2, 3, 4, up 1, 2, 3, like that. So its radius ends up being 5, if you find that. Its theta, not so nice. What do you guys get for theta? You can do degrees if you want. What was it? Did you guys get that for theta? In this case, if it is like degrees, I would probably, I don't know, if it's like one that you have to use your calculator on, I typically do degrees. So don't feel like you have to do radians in this. It's fine if you do degrees. So then this answer should be z equals 5 cis 143.13 degrees. Okay, did you guys get that one as well? Okay. So the next two you may not have gotten to, but this is one where it's positive and negative, and we go over root 2 and we go down root 2, right? So we can see that it's smack dab in the middle of that quadrant. So it's the one that's 315 degrees, or 7 pi over 4. And then our r ends up being the square root of 2 squared, or square root of 2 squared, plus square root of 2 squared, which ends up being square root of 4, which is 2. So this one should be z equals 2 cis 7 pi over 4. All right, and then the fourth one, a little bit weird. This, again, is the fourth quadrant. I was really liking that fourth quadrant, huh? All right, so if you set up your equation and you have tangent of theta is equal to the y value over the x value, we end up finding theta is equal to inverse tangent of the negative 2 over 8, which is like negative 1/4 if you wanted to reduce it. And it gives you a negative number. So did you guys see that? So we do inverse tangent of negative 5. So I got negative 14.036 degrees. But I told you I typically want them between like 0 and 360, so we're going to add 360 to it. So we end up getting 345.964. Does that make more sense where it is? Yeah. So we're going to have that. And then we're going to do our z equals our r. Well, did you guys get r? Square root of 68? Yeah? Yeah, you can leave it as square root of 68. I'm fine. Does it reduce out? Like, can you pull something out? You have 34, yeah. So cis 345.964. So some of them are not very pretty. It's okay. Power through. You can do numbers that are not pretty. In your life, you're not always going to have numbers that are pretty. Sometimes we have to go with it. All right, so can you do the opposite way? Well, the opposite way is really easy. So don't be worried about these ones. So it says express the following complex numbers in standard form and sketch the point. All we're doing is we're just simplifying what it has right there. Like we know cosine of pi over 3, right? What is cosine of pi over 3? 1/2. And then we know sine of pi over 3 is root 3 over 2. So as we multiply this 2n, we end up getting 1 plus root 3 times I. So it's saying sketch this point. So we go over 1, and we go up root 3, which is like 1.7, somewhere around there. And that's our point right there. Easy enough? All right, try the next one. So we're going to use our calculator to help us. So if it says 5.25, do we think this is degrees or radians? It's radians because there's not a little degree mark, right? So this is radians. So we want to make sure our calculator is in radian mode. So if I find my cosine of 5.25, I get 0.512 something. And then if I do my sine of 5.25, I get negative 0.859 something. And then I'm going to multiply that square root of 34 into both of them. So square root of 34 multiplied by cosine value. And I went up and grabbed it, or you could store it if you want. So I got 2.986. And then square root of 34 multiplied by, oops, the negative number. So I have minus, oops, 86, minus 5.08, or 008, is that what you guys have? And then that has the I with it. Okay, so if you were sketching this out, it would be over to almost 3, and then down 1, 2, 3, 4, 5, a little bit past 5, so somewhere around there. Okay. Okay, easy enough? Can you handle this? I'm telling you, easy homework ever. It's all stuff that you've done before. So relate it to things you know, and you'll be totally fine.